Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to be applying our solubility rules. Let's get started.
So let's work on equations with soluble and insoluble salts. Specifically, we want to look at molecular, ionic, and net ionic equations. So here is a very general equation given here. It's not even balanced. So before we do anything, let's go ahead and balance this equation. So I know I'm going to need a 3 here for balancing my potassiums, and that actually balances my nitrates and phosphates, and aluminums are good. Okay, so at least it was an easy balance. Now let's determine which salts are soluble and which salts are insoluble. So starting with potassium phosphate. I do have a rule for potassium. It is an alkali metal. It is a soluble salt and there are no exceptions. So I can be confident that potassium phosphate is soluble. So let me go ahead and put an AQ above potassium phosphate. Now let's look at aluminum nitrate. I have a rule for nitrate salts. They're mostly soluble and I have no exceptions. Therefore, aluminum nitrate, also a soluble salt. Now for potassium nitrate, it is not only an alkali metal, but also a nitrate, no exceptions. Definitely going to be a soluble salt. So AQ here. Lastly, aluminum phosphate. I do have a rule for phosphates down here. This is a mostly insoluble salt. Is aluminum an exception? No, aluminum is not an exception. So aluminum phosphate is insoluble. I'm going to put an S because this is going to precipitate out as a solid. Okay, let's rewrite our equation a little neater. Here we go. This is our molecular equation. Let's go from our molecular equation to our ionic equation. And the way we do this is we take all of the soluble salts and we're going to break those apart into their cations and anions. So here we go. This is our ionic equation. Let me show you how I got all of this. Potassium phosphate, because it is soluble, it breaks apart into potassium and phosphate. Now notice this 3 here becomes this 3 here. There are 3 potassium ions. Aluminum nitrate, also soluble, becomes the aluminum cation, and again 3 nitrate anions because of this 3 here turns into that 3 there. Potassium nitrate, notice it has a 3 here for balancing. That means we have 3 potassium cations and 3 nitrate anions. Now my aluminum phosphate is insoluble. It is a solid, so it remains the same. It's still insoluble. It does not break apart into cation and anion. Once we have our ionic equation, we need to pull out all the spectator ions. Now, spectator ions are ions that are the same on the reactant side and the product side. So if you look at my 3 potassium cations, I have the exact same thing over here on the product side. So I can take these out. Nitrates are also exactly the same on reactant side and product side. You may ask, what about phosphate and aluminum? Well, here they are ions and here they are bonded. So those are not the same thing. You cannot cancel those out. Those are not spectator ions. So I have pulled all the spectator ions out of my ionic equation. So I'm going to rewrite this a little neater. Here we go. And this is the net ionic equation. So my phosphate pulled down, my aluminum pulled down, and my precipitate, my aluminum phosphate, also pulled down. What a net ionic equation shows is it shows the reaction that is really going on. So these potassium ions here from my ionic equation, they're just hanging out in solution. They are not participating in the chemical reaction at all, which is why we pull them out of the net ionic equation. Let's do another equation. Here is my next equation that we're working with. Let's first check and make sure it's balanced. C2 lithium, 1 carbonate, 2 ammonium, 1 sulfide. We're good. Okay, so this is a 1-to-1 ratio. Perfect. Now let's determine soluble and insoluble. So starting with lithium carbonate, I do have a lithium rule. It's soluble with no exceptions, or if I happen to check carbonate, that is insoluble with lithium as an exception. So this is a soluble salt. Next, ammonium sulfide. I have an ammonium rule with no exceptions, or of course, if I happen to check my sulfide first, I have ammonium as an exception. So again, a soluble salt. Next, lithium sulfide. Again, lithium, there are no exceptions, or if you check sulfide, you would see lithium as an exception. And finally, ammonium carbonate. Ammonium is soluble with no exceptions, or carbonate is insoluble with ammonium as an exception. So again, a soluble salt. Let's rewrite a little bit neater. Here we go. This is now our molecular equation. Now let's go to the ionic equation. Remember, every salt that's soluble, we are going to break apart into cations and anions. So here is my ionic equation. They do get quite long, don't they? But let's see how my salts break apart. So lithium carbonate, 2 lithium cations, and a carbonate anion. Ammonium sulfide, 2 ammonium cations, and a sulfide anion. Lithium sulfate, again, 2 lithium cations, and here's my sulfide anion, and my ammonium carbonate, 2 ammoniums, and 1 carbonate anion. Now let's pull out spectator ions. Remember, they have to be the same on both the reactant and the product side. So let's see, here's my lithium. Do I have it over on the reactant? Yes, okay, so that is a spectator ion. Carbonate reactant, okay, carbonate on product side, that's also a spectator ion. How about my ammonium? Yes, it is the same on that side too. Okay. And finally, sulfide. Yes, that's exactly the same. So those are also spectator ions. Now, don't panic. I know we have crossed out all of our ions because they're all spectator ions. This is because all 4 of these salts are soluble, which means there is no reaction. So when you're asked to write a net ionic equation for this situation, you almost always put NR, or you can write no reaction. So there is no net ionic equation in this case.
Now hopefully you understand why table salt dissolves in water. I hope you found this video helpful, and thanks so much for watching.